I guess we can start with it like the whatever the the participants whenever they will be joining, because mostly they kind of join late a little. So whenever they will
Yeah,
be
it's
joining,
fine, fine.
yeah, we'll start with it. I'll stop my screen share, then we can, I guess you can start with yours.
Yeah, yeah, cool.
Okay, man.
Can you see my screen?
Yeah, it's visible.
Uh, cool. So yeah, it's a small session. I'm just telling about the Rust as a language. What are the things that are there? Uh, why you should be basically aware that why you should care about existence of a language, such a language, or worry about writing your projects in it, or about its ecosystem at all. So just a few tidbits about that. If at all you find it interesting, yeah, you can definitely contribute. Try making your first Hacktoberfest PRs in Rust. For that matter, like, community is very welcoming. So I mean, if you do good work, I guess there are good chances that your work could be accepted at any of the large number of open source projects that are hosted in Rust as of now. So I'll just get going. So yep, this is the point which comes to your mind at first. I mean, I already know lot of languages which solve a lot of use cases. Why bother learning yet another language? Because I mean, it's it's hardly anything that a language is solving a use case which wasn't solved before. Obviously there are use cases. It's not denying the helpfulness of a language, but on the same hand, there are specific use cases that some languages solve well better than others. So are better fit for certain use cases. For example, if I'm trying to write certain scripts which want to do some automation, I probably won't be writing that in Rust. That's kind of thing which I won't be doing, because in such a case, some scripting language like Python and JavaScript are more suitable for that matter. But there are use cases where I would bother writing them in some language, uh, right, which fits the use case. So it's more of a use case scenario. So I'm just trying to give you points why bother learning it. So there are a lot of operating system concepts that you read, like a lot of theoretical concepts about how a thread's managed, how is memory managed across threads, how to use locks, how to use semaphores across threads, all those things. So there are good constructs which are there in the standard library of Rust, which you can use while writing such system programs, and there are good example repositories where you can basically see how that code is written, and it's much more easier to understand in better structured language, let's say, compared to C++. And that too, I'm saying old standard that you probably have it in your the schools. So schools, I mean, your colleges included. Like, don't take it for your 10th and 12th schools for that matter. But yeah, I'm just saying, yeah, the old you get to learn an old standard, and even in that case, the concepts are not are more easy to understand, because there are good resources with which help you understand those concepts better. uh, One of them is the Rust book in itself, which I'll come to later. Then there is another thing which is called safe memory access, which is guaranteed by the compiler. So whenever so there are languages which have a safe memory access, right? So for a fact that C does not have a safe memory access, because you have pointers to the memory, and then you can do illegal memory access, uh, which you have not allocated, but you can still access because your system is at a lower level. You are allowed to access such a memory, but it can lead to errors, right? And at times you do that unknowingly. A program has some behavior in which it tries to access the memory which is outside of your control, but you but you don't realize it when you're writing such a code, right? On the other hand, to tackle that thing, we have garbage character languages like Java, and a lot of there are a whole lot of object-oriented languages at this point which have a VM, like the Java uses JVM. A lot of Java JVM-based languages like Kotlin and Scala are obviously using the same runtime, so they are always also garbage collected. Then there is Go. Then there is languages like JavaScript, for that matter. All of them are like have a garbage collection system where basically you create objects. After you're done with them or lose references to them, the garbage collection system, which is basically a runtime program. So you have your own program, and you have bundled another program with it, which only takes care of basically removing the references that are not needed in the memory anymore. So it runs time to time. So you need a runtime to manage all those things. So you cannot ship a strip down very small binary just like you do in C. When you compile a code in C, you get a very small binary which you can run anywhere, right? You cannot do such a thing in languages like uh, let's say Python and all, because you need a Python runtime also at that system you're running it at. So and for because that system in itself contains the garbage collector, um, um, to solve that error issue. So in Rust, there's a unique concept of ownership based memory management, where your compiler will guarantee that code which has unsafe memory access does not compile in itself, like, and you don't need a garbage collector for it to. So you still have a small binary which you can use anywhere in the sense, on the same type of architecture that you compiled for. Let's say you compiled for a cross 64 architecture, you can run that binary on a cross 64 machine. But you don't need things like a new runtime which has a garbage collector which can do that for you. If you compile it well and it runs, you are sure that it won't have any cross-thread memory issues, because it has guaranteed, so the compiler has guaranteed so. Then there are zero cost abstractions. So zero cost abstractions are basically there are a lot of features which you have in modern languages. The features like lambdas, right? So all of them, when the modern languages do so, they have a they have a cost associated with it. So there is a memory cost, or basically you need additional memory which is allocated on your heap to do all those things. But how Rust handles it is like, it writes whatever code you are writing, which has a zero cost abstraction in Rust, which is existent for almost all the modern features that you see in the modern languages, like pattern matching, or your lambdas. So for all those constructs, you have zero cost abstraction. So what happens is, the code which compiler will generate, it won't have any. It would be as good as someone wrote down those things without abstraction. So let's say I'm writing code in a language which does not have pattern matching, for example. So I only have if conditions. I don't have switch with pattern matching, or basically just like you have in Rust, there's a match expression. So you don't have all those features. But without using all those features, I'm writing a code by my hand, which computer can compile. So the point here is, the code which I write by hand is as good as, which obviously is obviously more handcrafted, because I can do things more fine-tuned in that thing. But handwritten code is as good as the abstracted out code which you write using Rust. So it's a great, if you don't really understand at this point, I just say just read more about zero cost abstractions, because like that's a great point to learn Rust, or language, a modern C++ also, for that example, because modern C++ also relies heavily on zero cost abstraction as the basis of making new features. So that's the thing. Then there are ecosystem. Then the ecosystem of Rust is like really welcoming, and there are like a lot of opportunities where the people really help you out learning things better, and you can grow a lot more as a person who understands deep down what's happening on a compiler level, or on a language runtime level, on other languages or Rust for that matter. So yeah, that will give you very good place to expand your knowledge in. Then what Rust is good for. So I mean, Rust, obviously, I just like I pointed out earlier also, like languages are made for use cases. So there are some use cases which will sit better with some languages and not with others. For example, um, um, I mean, I probably won't be using C to write my web server for that matter, because there are a lot of issues. I mean, I'm very low level to write it at this point. Like, I have to do a lot of abstractions are not there. There are not good frameworks where I could, do such a thing. And so there are like a lot of, and on the same hand, I won't also be using C for writing a script, for example. I On the other hand, I might not be using Python for writing a core kernel level component, which I ship in my kernel, because anything which I write in Python also needs a Python binary to run. So kernel is a very small piece of binary in itself. Like code. So it's like a 64 MB or 100 MB, basically. Bundle by itself. So if you have to like add more and more components, let's say Python runtime in it just to run Python code, that's simply not a thing that you probably want to do or are going to do. Or also, if kernel module, you don't want to make big kernel module, so C or C++ or Rust is a better suited language in those use cases, because they are much more closer to the metal. You don't need runtime for that. So that's why there are like good use cases where you should or should not use some languages. So but Rust, uh, I mean, surprisingly, is a language which works good as a general purpose programming languages in a lot of use cases, like not just very close to metal use case. For example, let's like I pointed out, you probably want to be using C to write your web application, but on the other hand, Rust is good enough to write both the kernel level code and your web applications, because there are abstractions good enough to sort out both of the use cases. So you can go low level so that you can write kernel level stuff, and you can go high level where you are just dealing with the uh, core program logic in your web app, and you don't really care much what's happening down the scenes. So yeah, you can do both the things, and it's good for both the use cases. People actually do both of them. um, so yeah, so what it's great for is like writing CLI apps, obviously. Then they are like writing web service and network services, because like it's so close to metal, and it compiles down to LL. It uses the LLVM. Com- Basically, it compiles to the LLVM bytecode, which is very low level virtual. LLVM form is low level virtual machine. It's as good as basically it's a ahead of time compilation. It's a lower level than your JVM compilation, because the JVM, you need a JVM binary to learn, but LLVM binary is generally very small binary, and it's as I mean, a lot of modern programming languages, not modern, basically the C++ and also use LLVM to compile to a system level, like LLVM bytecode, which can be run on a particular system, but it's like very much optimized to run at this time. So yeah, so since like it's very fast, you can do so. Then it's good for writing embedded systems, because writing for embedded systems. So why? Because like as I told you, like the binary size is very small. Embedded systems like your Arduino and all, they have very small amount of memory on board, right? Very small amount of CPU and memory on board, and you don't want to waste the CPU or memory just to run a heavy bloated programming language like Python, for that matter, because obviously it won't fit in that memory and CPU. So but Rust is a great language for that. And obviously with all the other things, and also large scale systems which are very much prone to errors. For example, blockchain, where you don't want to make memory errors which can introduce bugs. You absolutely at all costs want to avoid such things. It's a great language for that. In fact, uh, Open Ethereum, as a matter of fact, is written in blockchain. Is written in Rust. The Polkadot is written in Rust, and Libra cryptocurrency by Facebook is also written in Rust. So there are like a bunch of projects in that matter. Then you can also write front-end web apps using the WebAssembly, uh, using Rust. Also, it's not a very pleasant thing to do per se, because like there are better abstractions and constructs available in uh, JavaScript for that matter. But if at all you're planning to do so, it's still possible. There are frameworks for that. Like it's called U, if you want to check it out, YEW. So yeah, what makes it unique? There's a ownership based memory management. By the way, any questions till this point? Anyone?
I guess we don't have any question till now.
No questions yet, right?
Yeah.
Cool. So yeah, what makes it unique? So yeah, I told you like there's an ownership-based memory management solution which guarantees that there is a across threads. There is a memory safety at the compilation time. So if it compiles well, you can guarantee that on the runtime it won't have any memory issues across threads like you have in other languages. People run into a large a large set of bugs due to just this. Then even if you run into you write buggy code, the compiler is very verbose. It exactly points you out where exactly you are going wrong, and also points out the correct line or examples you should look in the Rust book, or uh, for that matter, basically the exact documentation you should look for to correct that error, or basically improve that particular part where you are going wrong. Exactly points you out. So that's a great thing, if you ask me. Um, so yeah, I'm just having a very small example here, like why you should bother it. I mean, how it happens. Very small example, not a right way. There are good articles just pointing out. So for example, let's say in C, you could have written a code like this, where you allocate a uh, certain memory, right? So allocated a certain space for a heap, the space for int in a heap on the heap. Then I add basically on the reference of that variable, I added a value, initialized the value, printed it. Then I also have to free the memory, right? um, so what's happening here is like this free construct I have to write. So I mean, obviously this is an int. You could write int directly in C also, but if you have to allocate a heap, then you gotta do this, right? uh, what on the other hand, if you are doing in Rust, you do this tilde sign, which basically says that you are allocating it on a heap. So when you are allocating in a heap, and you are done with it, the compiler by itself will write code, the the equivalent bytecode, which is equal to this line. So basically, it will allocate memory for this int, uh, right? Because you are allocating on a heap due to since you did this sign, and it has to free the memory. So once this block is exited, it will also free that memory. But this all is happening at the compilation level. So the compiled code that you have, the LLVM code, will have the code written which is almost equivalent to this. So the point being, you did not need to worry about that, but it happened behind the scenes for you, which I was like finding out. It's a great thing. Now a small ecosystem overview. So Rust has like all the batteries included for starting as a programming language. So you have a package manager, just like you have in other good languages like pip for Python, npm for your JavaScript, and Maven for Android, for Java or JVM languages. Yeah, so similarly, you have Cargo for Rust. It's a Rust package manager. You can download your pack dependencies for your binary application or library, whatever, and it compiles your packages and make distribution packages which you can upload them to crates.io. Crates.io, on the other hand, is a repository for publicly published crates. Crates is a terminology for Rust package. So less like I'm say npm package. On the other hand, like you call it a Rust crate. So there's a crate for regex matching, or there's a crate for some standard string operations. I mean, there could be things. So there's like packages are called crates in the Rust terminology for that matter, and they are hosted on crates.io, which is like the official repository for hosting crates. You can obviously host private packages just like you could on npm on the crates.io. Then you have your toolchain management solution. So since it's a compiled language, so you probably want to compile it for your architecture or cross compile it to a different architecture. Let's say I'm working on a cross 64 machine and I want to compile it for ARM to run on it on my mobile or somewhere else. So you need to cross compile. So all those things basically, installing for a different tool chain for cross compilation or different release status, like this I want to install stable or nightly release, things like that. You can manage all those tool chains and whatever is active. It's basically like your virtual what do you call uh, if you use conda for python, or if you are using nvm for node, it's almost equivalent to that. uh, for that matter. Then where to learn from? So like I could have taught you how to program in Rust, but obviously like that's a thing that I mean, I'm not the best teacher to tell you how to program. Like that should there are great other tutorials where you can learn, and obviously like it's a very small session where I just want to tell you more like what's happening in the space, so you can check out things and try to learn more at this point on your own. So yeah, so there are a lot of good tutorials on YouTube and elsewhere, but I'll say that the best choice still remains the Rust book, which you can access on this link. You can, like, obviously when you go to the Rust main website, you will find the access, uh, uh, basically link to this book. It has all the chapters in great detail. Like you can like simply read through all the chapters. It has like very detailed anecdotes to connect like why this thing was introduced in Rust, and why is it good practice, how other languages do it, and uh, basically you can reason about things when you are reading it from the Rust book. So while other things are there, still say Rust book still remains the best source to learn it. So yeah, exercises and examples are great in the book, so I cannot emphasize that enough. So okay, fine. So some people are there who want to get their hands dirty. Like I mean, they want to uh, just try out whatever are the cool things available at this point. I just want to you know try and do things and learn while doing things. But that works great for languages like JavaScript and Python, because like they're scripted languages and you can see instant results on your whatever you're writing, and they're easy to comprehend for that matter. There are some concepts in Rust which will require you to first of all study and then basically work on it. So I'll just still recommend to read until at least Rust book chapter 6 before attempt to go all in on experiments. So that's a personal advice, like because like otherwise you won't get like what other people's code are doing, or like how the stuff is happening. um, you need to know at least until this chapter. And but yeah, so is it mature enough that it has good frameworks for your use case? That's a question people ask. So obviously, like it's been quite some time at this point. So you have good wait, you have good web frameworks. So there's a Rocket web framework which is good enough for writing fast, secure web applications, and obviously like there are good enough abstractions that you don't miss from any other web framework that you have in any other model language. So that's the thing. Then there is Actix, a lot other more. You can find more about them on rvweb.org. There are good ORMs also. There's a Bazel, which is like the most popular in the community, where you can have a query builder for your SQL queries, which is almost as equivalent to the SQL queries, but it's obviously a good uh, type safe builders for queries. So you can try this out. Then there is Rust ORM. These are top two. Yeah, you can check all this out in RV web at web yet. I'm just telling about web stuff at this point because like that's what most college people tend to do, right? Also, if you want to write great CLI apps, there is a cursive library for that. So If you've used, like, if you have ever tried to write a CLab before, you might have learned about curses library, which is there for, and curses library, which is there for C++. Um, there's a cursive library for Rust where you can have a good CLI app made. A great example is the Spotify TUI, where basically you have your whole Spotify UI in a terminal user interface. It's pretty cool. I mean, I'll just show a preview to you if you haven't checked it out yet. I mean, just see this, like, you seriously have like all your Spotify things which you can do on the terminal itself. Uh, Pretty cool, if you ask me. So yeah, you can do all this crazy stuff like this on this. Wait, yep, cool. Uh, yeah. So what other cool stuff is happening? So there is Redux, which is like operating system which is written in Scratch from Rust. Um, from scratch in Rust, basically. So yeah, I'll say, like, the people, like the students, should definitely check it out, because they also offer, they also have their different summer of code, which is like different from Google summer of code. There is Redux summer of code. So if at all, like, you are just thinking like there are only one such program available, you can definitely check this out, uh, where basically you will be able to contribute directly on the Redux operating system. And this is a really good time to start if you are trying to do GSOC or some open source contributions in your next summer. So a good time to start contributing to this right now, so that you can take advantages of, to start early. So yeah, it's you can check this out. It's a great project. Then there is Dino. Dino is a JavaScript runtime which is written in Rust. It's actually written by the same guy who wrote Node.js. If you don't know, Randall. So yeah, it's written in Rust. It has all the safety that's associated with Rust, but you can write obviously your code in JavaScript and TypeScript. Um, and Actually, I should write TypeScript runtime, because that's what it majorly is at this point. Cool. Then there is Libra, which is Facebook cryptocurrency, which I pointed out earlier. Oh, when Ethereum is written in Rust also. Then there are like a lot more other projects which you can find in the awesome list, just like you can for all other projects. Yeah, and the last but not the least, the community is great. So you can check out this link. Find, I mean, you can find people lurking on their IRCs. You can, like, simply ask questions there. Like, there will be people who will be answering your questions easily and with good examples. So I mean, I solved a lot of my doubts when I was initially learning there, and people were like really welcoming and helping to solve your issues there. I mean, so that's a great thing to have. We don't have it really for lot other modern languages at this point, I would say. Yeah, that's it. That's all I wanted to talk about. Just quickly stop my presentation and I can take questions if there are any at this point.
Actually, Pranjal, I myself have a question. Like, there
Mhm.
has, like, you said there has been so many things are happening in the Rust ecosystem. So why
Mhm.
haven't people have heard about it like that much, or like in compared to the other languages, of course?
Yeah, so the point being, it's not as easygoing as other languages. So, I mean, obviously, people are there. Like, there are good communities. Like, even in Bangalore, if you ask me, like, there is a community for Rustaceans. Uh, it's Rust Bangalore. They hold like some meetups. Obviously, it's not that popular yet. Obviously, it's quite new at this point. It's still like 5 years that since it has become stable, and like there is a somewhat friction. So since everything is mostly done by open source community and not by a major backing, and obviously Mozilla was behind it and Mozilla did a lot of things, but at this point, like, there is like a good large open source community which is taking it forward. So there is not a huge corporate backing it, or basically people are not using it from very very long time. Things are changing obviously for the better. But at this point, it's just that people are not simply as comfortable to use it as compared to other languages, because it I mean, the people are comfortable compared to using C++. So and there's that's where a lot of this development is going at this point. And I mean, you can see a lot bunch of projects that people have made. For example, there are good tools. For example, there is a tool called as uh, uh, sil- I'm not sure, rip grep. It's called rip grep. I'll quickly show that. Wait. So, I mean, so if you check this out, it's the fastest grep solution, and like it can search across your file trees, if whatever the reject pattern you are finding, instead of grep, it's like crazy fast. It does it in like in milliseconds. Like even if there was like a huge set of folders where there were like at least like, let's say, 10,000 files where I was like searching for some strings, and it did in like uh, milliseconds. I'll say like you should check this. Also, there are like a lot of cool projects that are happening, but obviously since there's not a huge corporation that's pushing people to do it at this point, so yeah, there is not that much traction also. So that's the thing.
Yeah, actually, makes sense. But I wanted to ask, like, I guess you yourself must be using Rust for quite a while. So have you built something in this, like, as a personal project, you know, stuff like that?
I contributed to my GSOC project, the 2018 one, in Rust. Honestly, I did not get to uh, do a lot other things in that time, after that time period in Rust. I'm trying out a new project at this time, but it's in my very initial stage. I mean, I have I started working on it only a few days back. So yeah, I mean, but yeah, it's been a while that even I'm quite touched with this ecosystem. So yeah, I don't really have open source projects as of yet by myself, but I contributed to some open source projects before which are written in Rust.
Yeah, sounds really great. So I guess that was Xi editor, if I'm pronouncing it right.
Yeah,
Yeah,
it was Zion.
that was good. Yeah.
Yeah.
Uh, I guess uh, I guess nobody has any more of these questions. But yeah, I have a personal, I don't know what to say. This you're still an Arch guy, right?
Mm-hmm.
You are still using Arch as a primary operating
Yeah,
system.
yeah, exactly. Yeah.
So I always liked your setup, very intriguing. So if you can shed some light, like we today we have a little 5-10 minutes on our hand. If you can just shed some light on your setup and stuff like that, how the a software developer work, who is working in the industry and stuff like that. If you if you're comfortable with it.
Nothing great. I mean, yeah, I can definitely share, but I don't know if it like is it really something which okay, people
Yeah,
want to check it out.
actually eventually I was shifting to it, so
Yeah,
I wanted some personal ideas. That's it. Ignore that.
yeah, cool, dude. It's nothing like, dude. I'm using a pretty basic setup, so
Mhm.
I'm using Arch with KDE at this point. Using X for that matter, not using any Wayland or some other window manager because they don't really go well with KDE as of now. Uh,
Mhm.
if you're using GNOME, you can definitely use them. Uh, but otherwise, like it's a pretty basic setup, but there are like good turnaround that you have in like good tricks that you have in KDE itself, which are handy for that matter. I
Mhm.
guess I can show this at this time, but yeah, I can show a few, but we can like have another session for them if you ask
Yeah,
me.
sure. Definitely,
So
definitely. No problem.
so let's say if you know that I mean sometimes it happens like you are let's say whenever you want to start your system, so let's say I have this four desktop setup, right? You can see all those four, right?
Yeah, I can see it.
Yeah, you get the grid. So what happens, like when I'm working, I don't really want to be like all cluttered in one space. For example, right now I'm just using the Zoom and the browser, so it's in the fourth space, but I just simply don't want the applications to go in just like any random space. So I use some things for that. For example, like in KDE, what you can do is like you can assign properties. The Kevin window manager has these things, so you can have application settings where you can say that I want to, let's say I detected the window properties of this. So for example, I say this is currently in virtual desktop 3.
Hmm.
So I assign this property to it, and I'll say ki apply this, like force apply this, uh, and I'll say okay. Now what you will see is like whenever I'll open this application again, right? Let's say I'm on this and I open this, it will start. Uh, wait, yeah. So it will start in this because I assigned this property. So this is very handy. Like if you are using Linux, I mean, it's a great way to manage your Windows because you know that certain, it's a muscle memory that your ID exists in this space, your Slack exists in this space, your terminal exists in this space.
Hmm.
So that's a cool, neat trick. Uh,
Yeah, yeah,
but
it's actually it's a pretty neat.
yeah,
Yeah.
there are like some nitty gritty things like that only. Um I don't really have, like I used to have a really fancy setup at the point, but I realized like a lot of them I just simply uh, it's
It's
someplace
not in a,
boxed out.
yeah, you
It's
don't really use those stuff in a
I
daily life.
found that
Yeah.
it bogs down the productivity at some point, so I don't really
Hmm.
care at this point. Uh, but yeah, that is one of the few things that I still use and like about the window management. Uh,
Sounds great. Yeah. Okay, I guess we are pretty much to it. We can end this session. Thanks,
yeah.
Pranjal, for joining in. And the AMA session that we have with Piyush, it's starting at 5. So we
Mhm.
have a couple of questions, in a succinct questions in a, yeah, we have a complete list of questions that we have curated for you and Piyush.
Mhm.
It we won't take a pretty, well, like we won't take a very long time of yours, but still,
Mhm.
the session is starting at 5. I guess then we can rejoin.
Yeah, sure.
Okay then. Thanks, Pranjal, for joining. It was a great session, man.
Cool. Well,
Okay. Thanks a lot. Thanks a lot, guys. If the last session, the AMA session is at around 5 p.m., so you guys can join it at that time. So Piyush and Pranjal will be asking, the questions. We have a couple of questions with ourselves, and you guys can also ask your whatever the question you have in your mind. It could be related to development, startups, entrepreneurship, whatnot. These guys are pretty good with all of the stuff. Okay. I guess we can end this session. Thanks. Thank you all for joining.